current understanding of the human visual system has been effectively applied to reduce bandwidth and computation in foveated rendering algorithms. Yet our understanding of crowding effects in the visual cortex and temporal perception of flicker has not yet been applied to accelerate computer graphics applications. In this paper, we look into the scenario of crowd simulations, where animation rates can be reduced or dropped completely without being noticed by the user. The video being displayed currently contains a foveation level that only animates 23% of the characters in the scene, and will continue to increase as indicated in the bottom left. Our user study found that up to 99.3% of the characters can have their animations not performed to no impact to the average user, which can release resources for complex crowd behavior simulation and foster new acceleration techniques to be developed in this field. Although counterintuitive, the technique currently being displayed performed better than progressively reducing the animation rate as approaching the periphery. While dynamic foveation still had high level of success as an approach in our user studies, we found evidence that low frame rate animations may exceed the critical flicker frequency, which peaks between 20 and 50 degrees in our peripheral vision. This was more noticeable by users than the lack of movement, while still requiring some computational effort. We validated these approaches through 2 user studies looking at the previous scene of a wandering crowd, and 4 scenes of organized movement that are found typically in crowd simulation research. These scenes of organized movement also allowed us to study the pooling effect of the human visual system when perceiving multi-scale movement with our peripheral vision. Our results confirm that wandering crowd scenes had a statistically significant higher threshold for detection on both approaches, and indicates a tendency for detection closer to the fovea, where pooling regions are smaller, thus counteracting the crowding effect. Furthermore, we noticed further detection of low-frequency animations due to its relation to the critical flicker frequency. We also provide evidence of pooling behavior in the perception of organized movement with peripheral vision. Ventral metamerism between animated and foveated scenes was seen, where users were not able to see small-scale movement in areas far from their fovea. This novel understanding of our movement perception can be used to further develop techniques to make animation and rendering pipelines more efficient. For details and results of this user study, and our validation with an i3D headset, please read our paper. Thank you.